Hi, my name is Keyla Newball, and I'm going to present the results of our research titled Integration of Renewable Energy into San Andres Island Electrical Grid, presented in the paper along with Alvaro Zambrano and Professor Javier Rosero. So we're going to see a little about the introduction, the hosting capacity concept, the method used in the research, the results, and conclusions. Distributed energy resources have a growing rate in electrical power systems. In 2022, the growth in South America was of 7.4% with an integration of 18.2 gigawatts of installed capacity. The most used technology is solar energy, followed by wind energy. In Colombia, it has been promoted by Law 1715 of 2014 and 2099 of 2021 that gives some rules for the integration into the national interconnected system and has aims of reducing gases emission, diversifying energy matrix, and also having a more sustainable economic development. There are some specific areas called exclusive service areas, such as the case of San Andres Island, where the grid is isolated from the national interconnected system and it's mainly fed by diesel generators. There are some subsidies from the national government that for the fourth semester of 2023 were more than 57 billion of Colombian pesos for San Andres Island. And also the unit cost of producing energy is one of the highest in the country. So there is a necessity to have an energy transition that lower the cost of production and also makes energy more sustainable in a place that is considered biosphere reserve. The Energetic Transformation Mission of 2021 also states the necessity of involving or integrating these technologies without compromising reliability. The integration of renewable energies bring benefits but also challenges for the grid operator that needs to be evaluated according to the penetration level and the asset's characteristics. Some of the changes introduced by renewable energy are voltage raise and thermal overload, risk of exceeding the short circuit capacity of the elements, wrong operation of protection schemes, among others. In this sense, hosting capacity has been a term used since 2004, and that refers to the total capacity of distributed generation above which the network performance becomes unacceptable. It needs to be evaluated for each performance index of interest for the grid operator, and it will have different behavior according to the nature of the performance index evaluated. This is the model of the electrical grid of San Andres Island used as the study case. It has a radial configuration with 3 generation bus bars that has a total installed capacity of 64.9 megawatts. The energy produced is carried through the transmission lines onto the bike substation, where it is also derived to the schoolhouse substation. One of the circuits of by substation called Almendros is modeled to evaluate the integration of renewable energy in low voltage. This is the model of the Almendros circuits in DigSilent. It has a total load of 2.77 megawatts. Probability density function of solar generation is used to integrate the uncertainty of these kind of sources into the simulations, and it was calculated from the irradiance data measured by the Instituto de Hidrología, Meteorología y Estudios Ambientales, IDEAM, at the airport of San Andres, and finding that it matches a beta probability. So here is the method used in the research. The image shows the simulation flowchart. Through the integration of DigSilent PowerFactory with Python, Monte Carlo simulation was used to set 25 increasing penetration levels. For each penetration level, 1,000 iterations were performed, and renewable energy or solar generators were located at low voltage level according to a uniform probability function. The capacity of each generator is set or assigned as a fixed capacity of the transformer to which the node is associated, and a random number is generated from the probability density function of the solar generators to multiply by its installed capacity and have the uncertainty related in each iterations. A load flow is performed after, and voltages, feeders and transformers rating and losses are saved to evaluate the hosting capacity. Okay, so now I'm going to expose the results. The data is in form of graphics to summarize the findings for each of the performance index. The first one is voltage. So as expected, when there is integration of renewable energies, there is voltage rise. So this image is the minimum voltage registered in some nodes for each penetration level. And here we can see that the nodes at the end of the circuit are near minimum voltage regulation without the penetration of renewable energies. And when there is integration, the voltage rises. So this is positive in this case. In this image, we can see the maximum voltage registered for some of the nodes, the same ones, in each penetration level. And here, the nodes at the tail of the circuit are the ones that has more voltage variation. So are the ones that need to be monitored the most. We can see that for a penetration of twice the load connected to the circuit, in this case 5.5 megawatts, and there are variations of up to 10%, mostly at the end of the circuit. So there is a need to monitor the voltage, especially in these sites, so that the protection schemes can be adequated or changed according to these new parameters of operation. Also, the maximum voltage registered in all nodes for all penetration levels do not exceed regulation, so there is no hosting capacity associated with the voltage performance index. After we evaluated losses, in this case, in the image from the left, we have average losses registered in each penetration level for all the circuit. Here we can see there is a minimum that is found when generation meets demand. But this is true in this case for all the load connected to byte substation, as Almendro circuit is not isolated from the other loads in the substation. On the other hand, well, we can find a function that relates renewable energy integration with power losses, finding that there is a reduction of 3.33% per megawatt of installed capacity. In the image from the right, we can see that for more penetration of renewable energy, there is more uncertainty and the grid operation turns less predictable. So in this sense, the grid operator need to establish new prediction and control schemes that prevent instability of the grid, that could also depend on the availability to switch on different generators and also on the turbine generation change ramps of those generators. In this image, we can see feeders rating. So here is the maximum rating registered for some feeders in the circuit in each penetration level. And we have that for the lines at the beginning of the circuit. There is the rating lower, it goes down with the penetration of renewable energy. For the lines in the middle of the circuit are the ones that has more variation in the rating with a rising rating. And the lines at the end of the circuit also has very few variation in the rating. We can see that the lines has spare capacity to hold distributed generation. So lines rating doesn't have a hosting capacity either. The third performance index is transformers rating. In this case, is the most limiting factor for the integration of renewable energy in the grid of San Andres Island, and the limit or the hosting capacity is found at 5.5 megawatts. That is the double of the load connected to the circuit. So this is the hosting capacity found for the grid of San Andres Island under this methodology. And we also evaluated the emissions. So here for an average load with a penetration level of 5.5 megawatts, we can have a reduction of an average reduction of 0.87 tons of CO2 emissions in an hour of operation. And well, emissions also depends on the variability of the renewable energies. Well, in this work, we made a hosting capacity method that integrates Monte Carlo simulation with DigSilent PowerFactory and Python to be able to evaluate the hosting capacity. We have that it depends on the topology of the grid and also on the assets characteristics. And there is a need to model low voltage circuits. So the impact of the integration of renewable energy can be evaluated. In this case, the tails of the circuit for voltage rise are the most affected. Also, the integration of renewable energy changes the parameter of the grid, introducing the voltage rise, the change in the rating of the feeders and transformers. And for the grid study, we find that the hosting capacity is found with transformers rating performance index with an integration of 5.5 megawatts that is approximately double of the load connected to the circuit. Nodes in the tail of the circuits can have voltage rises up to 10%, which can alter protection schemes. So it's necessary for grid operators to manage the observability of the grid and adjust the protection schemes to prevent instability. The introduction of renewable energy lowers the power losses. In this case, we found that the reduction can be of 3.3% in average for each megawatt of installed capacity integrated. And there is an optimum of power losses when generations meet demands as generation is near consumption needs. And for San Andres Island grid, which was the study case we used, the limit of the 15% established by Resolution 038 of 2018 for non-interconnected zones is low for the capacity that the grid has to accept the integration of renewable energies, and it could be higher with the aims of reducing well gas emissions and also generation costs. Thank you.